So, welcome back again. We are going to discuss about subsampling mixers. So, what are the subsampling mixers? The high quality of CMOS switches has also been exploited to realize what are sometimes called subsampling mixtures. These types of SIM mixer exploits the observation that the observation bandwidth of modulation is necessarily lower than the carrier frequencies, affecting down conversion in the process. So, what are subsampling mixtures? As can be seen in figure, the higher frequency signal is sampled at the instants indicated by the dots. As can be seen in figure, the higher frequency signal is sampled at the instants indicated by the dots, while the down converted signal is shown as the lower frequency reconstruction. So, illustration of subsampling. The theoretical advantage of this approach is that it may be easier to realize samplers that operate at a frequency well below that of the incoming RF signal. Next, from the below figure, it should be clear that a properly designed track and hold circuit serve as a subsampling mixtures. So, track and subholding mixtures. In the sample mode, transistors M1 through M5 are turned on while transistors M6 and M7 are placed in the off state. Devices M3, M4 and M5 put a voltage equal to the common mode voltage level VCM on the right hand terminals of the sampling capacitors, while input switches M1 and M2 connect the capacitors to the RF input signal. In the sample track mode, transistors M1 through M5 are turned on while transistors M6 and M7 are placed in the off state. Devices M3, M4 and M5 put a voltage equal to the common mode voltage level VCM on the right hand terminals of the sampling capacitors, while input switches M1 and M2 connect the capacitors to the RF input signal. Because M6 and M7 are open, the op-amp is irrelevant in this tracking mode, and the tracking bandwidth is simply set by the RC time constant formed by the total switch resistance and sampling capacitance. Because the system operates open loop in this mode, it is easy to obtain tracking bandwidths far in excess of what can be achieved with a feedback structure. For example, it is trivial to obtain tracking bandwidths greater than 1 GHz in a 1 micrometer technology. In the hold mode, all switch states are reversed, so that the only conducting transistors are the two feedback devices M6 and M7. In this mode, the circuit degenerates to a pair of charged capacitors feeding back around the op-amp. The settling time of this system need only be fast relative to the slow sampling period rather than to the RF signal period. Although a subsampler is clocked at a relatively low frequency, the sampler must still possess good time resolution or else sampling error result. Another problem is that the sampling operation converts more than just the signal. Noise at the input to the sampler undergoes folding into the IF band, resulting in an unfortunate noise boost roughly equal to the ratio of RF and IF bandwidths. IF bandwidths. Noise at the input to the sampler and sampler undergoes folding into the IF band, resulting in an unfortunate noise boost roughly equal to the ratio of RF and IF bandwidths. Because the RF bandwidth typically exceeds the IF bandwidth by large amounts, subsampling mixtures can exhibit large noise figures. So, subsampling mixers can exhibit large noise figures, that is 25 dB SSB NF. So the settling time of the system need only be fast relative to the sampling period rather than to RF signal period. Although a subsampler is clocked at a relatively low frequency, the sampler must still possess good time resolution or else sampling error result. Another problem is that the sampling operation converts more than just the signal.